Hello everyone, welcome to my YouTube channel Target 100 in Mathematics by Shivesh Kumar Singh, and today we are going to talk about number system. Okay, number system means where we will deal with all types of numbers, whatever you have studied or whatever you will study in your upcoming classes. Okay, so let's start the lesson. See, you have studied about the real number and you know that any number which can be represented on the number line, like this is the number line, so its center point is 0. Okay, then on the right hand side you see numbers are increasing, means it is positive, and on the left side numbers are decreasing, means it is negative. Okay, just positive or negative, they represent the position of the number with respect to 0. For example, if I say -5, so what you will understand? You will understand that -5 is the number whose position is 5 units left from the origin. Similarly, if I say +3, so you will understand that this is the number whose position will be 3 units on the right hand side from origin. Okay, so positivity or negativity of the number, it shows the position with respect to 0 only, nothing else. Okay, so just now I said that a number which can be represented on the number line. Okay, so it means there are some numbers which cannot be represented on number line. Can you think about some numbers? Pause the video and think about some numbers which cannot be represented on the number line. For example, if I say 3, so you can say yes, 3 is here. Here is 3. If I say -9/2, -9/2 means -4.5. -4.5, it will be somewhere here. Yes, so we can represent it on the number line. If I say square root of 2, square root of 2 means 1.4141, like this. Okay, so you can represent it like this also. 1.414 means somewhere here in between 1 and 2 we can represent it somewhere. Okay, so whatever number we know, we can represent it on the number line. But is there any number which cannot be represented on the number line? Think about some numbers for a few seconds and then you continue with the video. Okay, now I will tell you about some numbers. Before that, can you answer me this question? Square root of 4, what it will be? Square root of 4. Yes, did you say 2? Very good. Okay, square root of 4 will be 2. So, what should be square root of -4? Did you say -2? No, this is the wrong answer. Now, for this you need to understand why square root of 4 is 2. Why? What's the answer? What's the reason for this? See, reason is very simple. Because 2 to the power 2 is equal to 4. 2 to the power 2 is equal to 4. So, whatever answer you are saying, we are saying that 2 is the answer for square root of 4. So, just make square of 2 and if you get 4 here, then your answer is correct. But here, if you do -2 square, -2 square means -2 times -2. It means it will be +4. But what we had in the square root sign? We had -4. So what you can see here? Here we are not getting the same number, same answer we are not getting after doing the square. And it means that square root of -4 is not equal to -2. Okay. Similarly, square root of any negative number, square root of any negative number will not be equal to any real number. You cannot get the answer for square root of negative real number. So these numbers cannot be represented on the number line. Okay, and in fact you will study in higher grades, especially in grade 11, about this, where you will deal with the complex numbers or imaginary numbers. Okay, it is for grade 11. So there are some numbers which cannot be represented on the number line. So you will have to be very, very careful with such numbers. So what all those numbers? When you have a negative number is inside the square root sign, then those numbers cannot be represented on the number line. Okay, now let's talk about family of the numbers. Like we have our family in our home. So similarly, numbers also have their family. Some numbers are bigger, some numbers are smaller, some numbers are in higher category, some numbers are in lower category. Okay, so for example, see, everyone in his family, say for example, you have the eldest person is grandfather or grandmother. Okay, we have grandfather or grandmother in our family as the eldest person. So you can take it as a real number. Okay, so real number is like grandfather in our family. Okay, just now I told you, my dear students, again I am telling you, whenever you will go to grade 11, you will study another number which will be bigger than the real number also. Okay, so but so far for you, real number is the biggest category. Okay, now real number, this grandfather, he has two sons. First is called rational number, we will discuss in detail. Rational number, what type of numbers do you see as a rational number? It is like say 2 over 3, or you can say -1, or you can say 2.5 or 1.7, square root of 3, like all these numbers, sorry, not square root of 3, we will discuss these things in detail. So like all these numbers are called rational numbers. And another son of real number, another category of the number is irrational number, where you have square root of 2, square root of 5, or 1.314798014, like this. Okay, not ending numbers. And now here you see, for the rational number, we have further family for the rational number, but for irrational number, we don't have anything. Irrational number finish from here. Okay. Now, for rational number, we have another category of the numbers as integers. And how do we write integer? We denote it by Z. It is like, it is from a German word Z, because you can ask this question that here we don't have any Z in this spelling. So why we are taking Z? Okay, so it is from the German number Zahlen. It means an integer. Okay, so Zahlen is taken from, Z is taken from the word Zahlen. So that's what we take, Z for the integer. Now, integers, like it is maybe positive number, maybe negative number, but without decimal point. -3, -2, -1, 0, 1, 2, 3, 4, like this. Okay. So you can see here, we don't have any decimal point in the integer, no fractional value in the integer. Okay, just remember all these things. Now, next is whole numbers. Whole numbers is denoted by W. Whole number is denoted by W. Okay, and what all these numbers are? Whole number starts from 0 and then counting numbers 1, 2, 3, 4, 5, like this. These are the whole numbers. So it starts from 0. Okay, and the last person, last member in this family is natural numbers, and natural numbers starts from 1. They are counting numbers actually, 1, 2, 3, 4, 5, and like this. Okay, and natural number is denoted by N. So in our further upcoming questions, wherever we have to write natural numbers, I will write N only. W for whole numbers, integers for Z, and rational number we will deal with like Q. We will write as Q. Okay. Now, there are some other statements also what you need to understand. And what are those statements? Try to understand them. Every sentence, every statement, you will try to understand in a better way. Okay. And if you have any confusion, you can write in the comment. Okay. I will again clarify you this. Now, the first statement is, all natural numbers are whole numbers. Everyone, try to understand. If in this family, if a number comes down, down to another number. For example, first I said natural number, then I said whole number. So natural number here in the family, up or down, it is down. In the hierarchy, it is down, and whole number is up. So if the first number is down and the second number is up, then you can say word or, and then it will be correct. Means all natural numbers are whole numbers. So natural numbers means 1, 2, 3, 4 I said, and whole number means it is also the same but including 0. Yes. So it means this statement will be correct, because you can say whatever natural number you will count here, that will also be a whole number. Yes or no? Now, second one, all whole numbers are integers. Now you see, I have taken one category as whole number, which is down to integers. Integer is up. So it means this statement should also be correct. Okay? Or otherwise also, whatever whole number you can take, that will also be an integer. Okay? Now, but its converse will not be true, my dear students. Remember this thing. For the first, if I say all whole numbers are natural numbers, then it will be wrong. Because whole number means you can take 0 also. 0 is a whole number, but 0 is not a natural number. Okay? So reverse will not be correct. Okay? In second case also, you see, if I say all integers are whole numbers, like this reverse order, then minus 2 is an integer, but minus 2 is not a whole number. Okay? So reverse order, it will not be correct. So how you will say mathematically this type of statement? You will say all whole numbers are integers, but converse need not to be true. Now, these questions, these type of statements will help you in short type questions, short answer type questions. Okay? Now, another one is all integers are rational numbers. Now, you see, integers, here it is down, and rational number is up in the same family. Yes, in the same hierarchy. So, this statement also should be correct. And otherwise also, you can take some examples. Integer means minus 4, rational number is also minus 4, no problem. Okay, so whatever integers you will take, that will also be a rational number, but its converse will not be true. For example, if I take 5.4, it is a rational number, but 5.4 is not an integer. Okay, so its converse need not to be true. Now, another statement is all rational numbers are real numbers. Now you can see rational number here it is down and real number is up. So this statement should also be correct. Okay, so whatever rational number you consider, positive, negative, fraction, okay, whatever you consider, that will also be a real number. But real number, all real numbers need not to be a rational number. For example, if I say square root of 5, square root of 5 is a real number because you can find its answer. You can find it on the number line. But square root 5 is not a rational number. We will discuss about the rational number in detail in another video. Okay, not in this video, otherwise video will be very long. Now, the last one is all irrational numbers are real numbers. All irrational. You see, irrational number is down in the family and real number is up. So, all irrational numbers are the real numbers. Okay, but all real numbers need not to be an irrational number. Okay, example, like many examples I have told you. You see, square root of 3, it is an irrational number and it is a real number also. Okay, but if I say 4, 4 is a real number, but 4 is not an irrational number. You understand these things? Okay, so if in any problem in any statement, you must write in the comment. Okay, now let's talk about in detail about decimal numbers. Okay, slowly we are approaching to rational number. Okay, now decimal number means Any number if you see with the decimal point, for example 4.2379 like this. So whenever you see this dot, it means it is a decimal number. Okay. Now you might have noticed two types of decimal numbers. First is terminating. Terminating decimal means when the decimal point, decimal places terminates after few places. For example, 2.357. Now nothing after 7. Okay. So it is a terminating decimal because you can say that after decimal point we have 1, 2 and 3 decimal places. Yes. So if you can count the number of decimal places after decimal point, then it will be called terminating decimal. Okay. Now another category of the number is non-terminating decimal. Okay. Non-terminating, as name is telling, terminate means finish. Okay. So non-terminating means a decimal number which will not be finished. For example, 1.414141414141 like this. Okay. Or another example I am writing for you. This was the first example. Second example can be 2.730519023401 like this. Do you find any difference in number 1 and number 2? Pause the video and write the difference in the comment. Okay. See, what's the difference here in the number 1 and number 2 you are finding? In number 1, you see, it is not finishing. It is non-terminating. It's okay. But you see, there is a pattern. Only these two digits are repeating. Yes. And here we are not finding any pattern. All numbers are in a different pattern. Okay, there is nothing, no pattern. We cannot find that yes, next number will be this. But here we can say yes, next number will be 41 again because it is a pattern. But here you cannot say yes. So it means non-terminating numbers can also be divided into two categories. First category will be repeating decimals. Repeating decimal means, as I have told you, this number 1 example, this is a repeating decimal, or you can write another example yourself. For example, 2.333. What pattern you are finding here? That the one digit is repeating itself. Okay. So after the decimal point, it is not terminating. It's okay. But we have a pattern for one number only. And another last category will be non-repeating. Non-repeating like this example number 2 I told you. Okay. Or you can take another one, 1.374910201479 like this. Okay. Now, my dear students, terminating number is also a rational number. What we say? Rational number. And this non-terminating but repeating numbers also called rational number. Non-terminating but repeating, they are called rational numbers. But if you have non-terminating and non-repeating number, then this type of number is called, what we say? Irrational number. What we say? Irrational number. Okay. So again, I am revising for you. Terminating or non-terminating but repeating, they are called rational numbers. Okay. But non-terminating and non-repeating, they are called irrational numbers. Okay. So these are some types of numbers. I hope you understand all these numbers in detail. In my another video, I will explain you about the rational numbers. Okay, how to identify that any number is rational or not, which will be really very important video for you. Okay, so don't miss to watch that video, and I am sure these types of videos are helpful for you. And if you think that it will increase your knowledge, then like and subscribe my channel and share with your friends. Thank you.